Yeah.
That's the entry cost of attaining this durable good.
Yeah.
But isn't the good itself, having an established network of like sellers and stuff, isn't that itself a durable good?
Yeah, no, I think that's a good point. So I've sort of been implicitly assuming that the time to build is the same as the time to depreciate, which need not be the case. And it could be that what went on with Groupon is that everyone thought the Groupon market's going to last for a very, very long time, but it's easy to acquire it quickly. And so I'm going to enter, even though it's a durable, because I think the market will last a long time. I don't think that's really that plausible, because I think that actually the Groupon market is probably not going to last for that long. And so that shows that the companies, both have to be able to enter quickly and exit quickly, and so it's probably not a durable, but that is a good point, is that there can be asymmetries to coming in and getting out. On the other hand, the medical industry has been really slow to even train people to enter the industry or adopt new technology, which shouldn't be as durable, and their changes, the increases in demand in the medical industry, are expected to last and continue to get greater over a very long period of time. So because of institutional features that we discussed in the first class about occupational licensure, there have been a very slow adjustment there, even though the run over which the demand is increasing seems to be a lot longer. So institutional and legal context are going to be crucial. And it's also really important to consider that, the short run and the long run are not abstract things. They should correspond in your mind to real periods of time. So when you think about short run, you should be thinking 6 months, a year, or whatever, or you should sort of denote to yourself, here's sort of about the time period that I'm thinking about the shift taking place over. Not just say, well, this is the short run and that's the long run, because it all matters the actual period of time and how that compares to the actual goods that are being used, what the right prediction is to make. Okay, so let's consider a simple example of Le Chatelier's principle. So imagine that the production function is x to the 0.4 times y to the 0.4. Now, Yifei, I'm actually going to ask you to do something. So can you derive the cost function associated? You can either do it up here, or you can do it over there, or whatever you want to do.
Production function. So I'm supposed to maybe cost.
Yeah, imagine that the price of both of the goods is $1. What's the cost of producing?
So O is
The output.
output. So the cost of production would be.
If you want, you can use the formula that we derived in class, or you can come and do the Lagrangian, or.
X is the quantity of.
X and Y are two different inputs.
And the cost of.
And each one costs $1 to buy.
To buy.
Yeah.
So this is the input.
Yeah, this is the production function, like we discussed on Tuesday. So what's the cost of producing O? Well, let me put it this way. So what are the right factor proportions? If notice that we have x to the 0.4, y to the 0.4, so it's completely symmetric. So if the prices are the same, what's the ratio of x and y that you should buy?
Should be 1 to 1.
1 to 1, right? So what that means is that O is equal to x to the 0.8, right? Because x is equal to y.
Yeah.
And so that means the production function is O equals x to the 0.8, which is the same as saying that the cost of production is O to the 1 over 0.8, right? Does that make sense? Okay. So the cost is, sorry, that's how much x you need to buy is O to the 0.8, but then you have to multiply that by 2, right? Because you have to buy both x and y. So it's 2 times O to the 1.25, right? Okay. Now, Xulun, how do I pronounce it? Xioulun? No, nobody knows who that is. Okay. He's not here. Okay. So that, how do we derive the marginal cost? Well, we just take the derivative here, and we get the marginal cost is 2.5 O to the 2.25, right? Okay. Now, in long-run equilibrium, imagine that the price is 2.5, right? And the output is going to be 1, right? Because they said marginal cost equal to price, and so that means that O to the 0.25 is equal to 1, so O is equal to 1. And therefore, x and y are both going to have to be 1 to produce that, right? Okay. Now suppose that y is fixed in the short term at the long-run equilibrium level of 1. Suraj, can you tell me what the short-run marginal cost will be in that case? Or you can come derive it. So y is fixed in the short term. Y is just equal to 1 now. What is going to be the short-run marginal cost? Well, first, what's the short-run total cost?
Short-run total cost would be 2, because it's 2 times output 1.25.
Well, no, so x can still be adjusted in the short run.
I'm sorry?
We want it as a function of output, right? So x can still be adjusted in the short run, only y is fixed in the short
So
run.
if y is fixed at 1, then you want x to be 1 too, right?
No, but what's the short run supply curve? Or short run total cost curve? So as a function of output, you can still adjust x in the short run to adjust output, right? So what's the total cost as a function of output in the short run? So y is fixed at 1. So, okay, I'll just do it. So if y is fixed at 1, right, then the production function in the short run is 1 times x to the 0.4, right? Is equal to the output, right? And so the short run total cost is that we invert this and we figure out how much x you have. So you have O to the 1 over 0.4 is equal to x, right? And so the short run costs are going to be the cost of purchasing the y, which is 1, plus the cost of purchasing the x, which is x to the 5 halves, right? Right? So it's 1 plus O to the 2.5, which means that the marginal cost is going to be 2.5 O to the 1.5, right? Now, what about short-run average cost, Zhengling? Or, sorry, Jialing. Jialing, sorry. Jialing, what is the short-run average cost? In this case?
It's the total cost divided by,
Yeah.
divided by,
There. Divided by output, right?
yeah.
So what's that?
X to the 0.4.
This is the total cost, right? What is this total cost divided by O? plus,
O to the 1.5.
exactly, that's right. Okay, so, the two things that we should note are that, first of all, the long-run marginal cost, as it's raised to a much smaller power, is going to be much more elastic. It's going to be much more flat than is going to be the short-run marginal cost, and I'll show you a graph of that in just a moment. But these are equal to one another at equilibrium, right? So the marginal cost is 2.5 O to the 0.25. The marginal cost in the short run is 2.5 times O to the 1.5. If we plug in the long-run equilibrium output of 1, right, these are both equal to one another. And this principle is called the envelope theorem. And we'll see in just a second why it's called that. So here's the picture. At the long-run equilibrium of 1, the short-run marginal cost is much steeper than the long-run marginal cost is, but they coincide at the long-run equilibrium. Right? Okay. Now, to really understand why it's the envelope theorem, we have to compute the long-run average cost and the short-run average cost. So remember that the long-run average cost is 2 O to the 0.25, and we just figured out that the short-run average cost is going to be O to the 1.5 over Y plus Y over O. And this gives us what's called the envelope theorem, which is that the long-run average cost is the lower envelope of the short-run average cost. That means it's made up of the bottom points of the long-run average cost curve and is tangent to them at all of those points. So the marginal costs are the same at the point where the long run is optimal. The average costs are identical and tangent at the long run optimal points. And this basic principle of the envelope theorem shows up all throughout economics. So let me just show you the picture. So here are a bunch of short run average cost curves drawn from what I showed you for different values of y. Here is the long run average cost curve. And you see that at the points where these would be the optimal choices of y, they coincide with the long run average cost curve, and they're tangent to them at that point. And basically the idea here is that the marginal cost, Eric.
So why does the long run average cost start at 0? I mean, I understand that in the long run most of the fixed costs are variable, but aren't there some costs like entry into the market that would make the average cost start at
Sure. I mean, this is just one mathematical example we did where there's no fixed cost.
All right, so it doesn't always start.
No, not necessarily. So the long run average cost curve, is the lower envelope, and what that represents is the idea that if you're choosing the optimal quantity, then the marginal cost is equal to the same thing if you can adjust the other quantity as if you can't, because you're already choosing the optimal quantity. And that's called the envelope theorem. And that corresponds to the fact that the slope of the average cost curve is the same as in the long run and the short run if you're at the optimal point of the short run average cost curve. Okay. So again, we want to interpret these responses to different durations, the short run and the long run,